All right, here we are again. So we have a lot to go over tonight, of course, as always. So what I'd like to do is get back to where we left off yesterday with our discussion about chapter 12. And then there's a couple of calculator things I wanted to go over because, yesterday I was having an issue with one of the problems and I had to do some research to find out, what was going on. It surprised me a little bit. But you never know. I mean, sometimes, when you use calculator functions, there are restrictions that you may not know about. Sorry, all right, let me get my document open here, and then we can get started. So, also, I'm going to show you something I've added to Blackboard. And so, yes, I think I mentioned in one of my emails that I've written the midterm, but I have to be very careful about putting it in MindTap because if I just stick it in there with the others, what it will do is it'll see that as another another assignment, and it'll average them all together. And I don't want that. I want that to have its own separate grade. So I wrote to the company and asked them how to do it, and they did send me some instructions, but it looks like it's going to be very complicated to get it set up properly. So I'm thinking that probably it'll have to wait till the weekend, but you'll have until the very last day of the class to get it done. So it shouldn't be a problem. And I want to make sure we get it right the first time. Okay, not if I just put it in there, it may not even be possible to fix it. So I've had enough experience with Cengage to know that certain things are doable and some things are simply not. And so we don't want to make any mistakes. In fact, that reminds me too about this business about the Excel assignments. I don't know how this happened, but somewhere in Blackboard, there's a place where it's showing people have zeros for their Excel. I had nothing to do with that. I didn't set it up. I didn't ask for it. So I don't know why that's happening, but you can completely ignore that because what's going to count is what spreadsheets you sent me by email and not what it says in Blackboard. Okay, it's not set up to correct those Excels or even keep track of them. So whatever it says, just don't even look at it. But I'm glad you brought that to my attention. So in the future, I can have that fixed. So now, as it turns out, almost all the grade for this class is coming from the MindTaps because you've got all your assignments and your three exams, and they're all being done in MindTap. So if I set it up correctly, your average will be very obvious. Your average for everything except for the Excel, which is only, I think, 10% of the grade anyway. So that way you'll always have a very clear idea of where you stand with your grade. Okay, I know it's very frustrating when you have no idea how you're doing. So I want to make sure it's clear that it'll be possible to always know exactly where you are. Okay, but I've got to set this thing up correctly. So that's what's holding it up a bit. The other thing is that if you look in Blackboard, what I did was I wrote some review questions for the first midterm, and I'll be doing the same thing for the second and the third. So this way, I think, discipline like this, the best way to learn it is with practice. So I don't, the slides are great, but I don't think we have enough practice with these problems. And so we're going to spend at least some time, possibly as early as Thursday, going over these problems so that we can get more practice testing hypotheses and all the rest. So let me go quickly show you where those are found. First, let me save this document. See what I'm doing. I'll show you where they're located. So far I've only posted the ones for chapter 9. The rest will follow very, very soon. Because I have to go in there and, finish. They're not all completely done, and I have to make sure that the answers are right and everything. So, but at least the ones for chapter 9 are ready, if you want to take a look at them. All right. Okay. That's done. All right, let me get into Blackboard real fast. Let's see, where is that? Ah, here we go. All right, so now when you look at my Blackboard, it's going to be a little different than yours. Um, I've got stuff in there that you aren't able to see because I didn't click on the little buttons that say make this visible to the students. So, so here's 9. And I'll draw your attention to these first two documents, Chapter 9 problem set and problem set number 2. And again, these are just new problems that I wrote for us to get some more practice. Now, there also will be some for 10 coming up very soon. And in order to tie it all together, there's a document that I'm working on called Sample Midterm Number 1, which ties together everything from 9 and 10. And it's meant to be like a way of getting ready for the first midterm before you actually take it. So that way, by the time you get there, you'll have had plenty of practice with these types of problems. Okay. And then I'll be posting the solutions, of course. So, so this way, by the time we're done, we'll have had tons of practice with all these concepts. All right. So that's the important thing with statistics. It's all about practice. And of course, in the meantime, you're getting really comfortable with these calculators, which is good, as well as Excel, which is wonderful. And you'll be able to use those skills in other classes. And so, what I need to do now is open up 12. And let's go back to where we were. And then later on, we're going to do some Excel. So here it is. Now, remember, everything in this chapter is related to the chi-square distribution. So even though that's not the title, you can think of this chapter as applications of chi-square. And they are quite interesting, as you saw. The last one we kind of got tripped up on. I was having an issue with the calculator. And so now I've taken care of, I resolved what the problem was. All right, so quick reminder, yesterday we looked at goodness of fit tests and tests of independence, and then we started to look at testing for inequalities of 3 or more population proportions. So the goodness of fit test enables us to tell or test formally with a hypothesis test whether or not the data that we have follows an assumed probability distribution. So the example I gave was the normal distribution. We often need to ensure that our data are normal before we carry on, because otherwise the results that we get will be, let's say, less accurate or even maybe not accurate at all. So, but here we're doing simpler versions of the same thing. So they showed us, for example, oh, and by the way, with this type of setup, the null for a goodness of fit test is always going to be that the data do follow whatever distribution you're assuming. This is, by the way, this is a consequence of the way the test statistic is calculated. So it has to be set up this way. And if you notice, it's a yes or no hypothesis. Okay. And when that happens, then it's going to automatically be run as a right-tailed test. Okay. So let me just remind you too, this is the so-called goodness of fit test. So this is how we always start. And of course, we specify a level of significance. The test statistic is kind of messy. Yeah, so remember this from yesterday. So this test statistic follows the chi-square distribution. Okay, and that's why it's in this chapter. So over here, the summation operator runs from I to K. K is the number of categories in the data, depending on how we've defined it. First, we have F and E. What are those supposed to mean? Okay, so remember, for a setup like this, we're going to have two types of data. We have the data that we actually observe. So this is the observed data, and EI is the expected data, which means what it would look like if it followed our distribution exactly. So what you're effectively trying to do is find out how close F and E are to each other. If they were all identical to each other, this test statistic would be zero. But if they're all over the place, then the test statistic will get very large, and you'll eventually be forced to reject the null hypothesis. Um, that would mean that the data are not following your distribution. So let's see the example from yesterday. And yes, remember too, there's only one choice for the critical value. Unlike our other cases where we had multiple choices, the right tail is alpha. K minus 1 is the degrees of freedom. Okay. Rejection region is in the right tail. So then you make the comparison and you're all set. Oh yeah, that's right. We had the marketing company. So the null was that the proportions for each of the three companies are 30. PA is the proportion in population A. EP is 50% for company B. And for C, it's 20. The alternative is that they're not the same, or they don't follow this distribution. Different somehow. Okay, now if you notice, these are proportions, but we need actual totals. So what we're going to do is assume a sample size of 200. That way we can calculate frequencies, which is what the calculator requires frequencies. It will not accept proportions like this. So with 200 in our sample, and by the way, because there's three companies here, then these are each considered to be a category. So K equals 3. And so the frequencies that we're looking for First one is the proportion who shop at company A, so 30, 60. Okay. Then we do the same thing for company B, is 50%. And then the last one was 20%, which is 40. Now, what we have to do is compare them with the actual values that we find in our sample. Those are the observed frequencies. And they have to give that to us. We can't figure that out. And they're telling us that it's 48, 98, D1. So you can think of this as F1, F2, and F3. So if you plug these in to your test statistic, it'll look like this. Now, if you remember, they did make a mistake here. So you're going to have 60 minus, sorry, 48 minus 60 squared over 60 plus. So remember, the F always comes first. 98 minus 100. And then finally, 51 minus 40 squared over 40. So we pop this into our calculators and discover so this is going to give us first term is 2.4. The second term is 0.04. And then we have approximately 3.025, which adds up to 5.465. But now we can then compare this with the critical value. And of course, if you remember, they gave us an alpha of 0.05. And because there's only three categories, 2 degrees of freedom. Now, I just realized I never opened up tonight the chi-square table. Let me go grab it. It's probably still on the downloads. There we go. Now remember how this works. The top gives me the right tail area, which in this case is 5%. And we have 2 degrees of freedom. Two degrees of freedom combined with 5% in the right tail gives us a critical value of 5.991. So therefore, that represents the cutoff point between the rejection region and the rest. And of course, our test statistic was 5.465. So based on these results, we do not reject the null. And of course, the null is that the data follow our assumed distribution. Then I just remembered later on, when it was too late, that there's another way we could do this with the calculators. I'm pretty sure we didn't do this last night. What we could have done instead is we can enter data into lists. It will figure out the p-value for us. Okay, not the critical value, but the p-value, right? So, but that's all we need. Remember, we're just comparing that to alpha. So here's what you should probably do. Um, just to make things easier, let's do this. We'll put, oops, sorry, wrong one. Let's put observe the F's into list one. And then, of course, put the E's into L2. All right. So we know, all right. So let me remind you how to put data into the list. And we'll do it while we have this wonderful chart right in front of us. So remember what you have to do. Oh, well, they're kind of out of order, but that's okay. We'll get it straight. So you go to stat, enter. That brings you right to the lists. Now, when you get there, clear out old data first. You don't want, if you have old numbers in there, you're just asking for trouble. Here's what you have to do. Go to the header of each column with your arrow keys and then hit clear. There's a clear button in the extreme upper right-hand corner. So make sure you always do that first. Get all that old data out of there. And then you're going to go to L1. You'll enter the three F's, which are 48, 98, and 51. And then we'll do the same thing for the E's. And they were 60, 100, and 40. All right, so let's do that, and then I'll show you what to do with these results. Remember, stat enter, erase everything that you don't need, and put those in their place. Okay, so I'll give you a minute to catch up. So once you're done, go ahead, stat, go over to tests with your arrow key. And this time, I can't believe I forgot about this last night, but I was focused more on doing the algebraic approach. But if you scroll down far enough, you're going to see that there is one called chi-square GOF. I wonder what that stands for. You guessed it, goodness of fit. And if you do, once you get there, it's going to ask you where's your observed data. In other words, the F's, and make sure it says L1, expected, L2. If they're not right, to type list a list, like would hit second one. Okay. It's always second followed by the number of the list. Now, there's just one wrinkle here, the degrees of freedom. It's going to ask you for that, which is not really a problem because just remember, it's just K minus one. So DF, degrees of freedom, 2 there. Scroll all the way down, hit calculate. Don't worry about the color. It just seems like a strange place to put it. Enter, and what you're going to see, actually, you know what? I just realized they do give us the test statistic, but instead of giving us the critical value, so don't have to worry about it. And because our alpha is only 0.05, so remember how this works. P-value less than or equal to alpha means do not reject. I'm sorry, it does mean reject. It's only when it's greater than, strictly greater than. Means, of course, do not reject. And so here, p-value is 0.065, alpha is 0.05. So we're going to get the same result we did when we calculated the test statistic and the critical value, do not reject. Means that the data do follow assumed distribution. Right. Now, I'd like to point out one more thing. If you look back at the calculator, underneath there's this mysterious entry CNTRB. What is that supposed to mean? 2.4, 0.04, and 3.025. Well, what they've done here is they've shown you the 3 components of that test statistic. They should look familiar up here. There they are, 2.4, 0.04, and 3.025, in case you want to know what they are, and not just the total. So that's why that's there. It just confirms that we did it correctly. Okay. Wow, that was interesting. So The next thing we tackled was tests of independence, where we used matrices for the first time in our calculator. Who knows, maybe for the first time in our lives. So this one is a little bit messier, as you can see, because you've got double sums, which means you're reading across rows and columns. So we're looking at categories like, for example, we saw yesterday gender and beer. I think it was beer. I think I also had an example with Starbucks. It could be literally anything. So the null is that um, the variables are independent. So it's set up just like the goodness of fit. Okay, and the test statistic, as we just saw, is a more complicated version of what we had with goodness of fit, because we're taking into account both rows and columns, not just columns. But as it turns out, we can do this directly in, oh, it is beer and gender. Okay. Our calculators, as long as we know what we're doing. So we went ahead and took this data totals and we entered it into a matrix. Okay. So enter the data. And by the way, when I say the data, I mean the observed frequencies into a matrix. All right. So in order to do that, it's either that or do this whole procedure by yourself, which you can do it if you want. It seems a little unnecessary because you've got this wonderful calculator here. So what you're going to do is hit second X inverse. Now you're going to see a whole bunch of letters. Here's A, and it's going to have some dimensions in here. If they're not the same, now our matrix here has 3 rows and 2 columns. Down here we have 2 columns. So we will tell the calculator that our dimensions are 3 by 2. Just by literally typing over, but first you have to hit the edit button. Um, and of course, the way to get over there is the arrow key. And then you can hit enter. And then when you get there, you'll see an actual picture of the matrix that you asked for. And you're going to now type the numbers. Oh, I just realized I didn't fix. Sorry, I'm doing this wrong. I should have changed it to 3 by 2. So let me fix that picture. And now just enter these numbers. Okay. So we have 51 and 39, 6 and 21, and finally 25 and 8. So the ones on the left are the male customers, the one on the right are the female customers, and then the rows are the three beer styles. So it's hard to tell by looking at that table. What we're trying to establish is if the proportions are the same. In other words, if is it true that in all three cases men prefer it by the same amount? It's you just want to make sure that the proportions are the same between the two genders. Now, it's a little tricky to see it at a glance because it's pretty clear that the total number of men in the sample is larger than the total number of women. So really what we're focused on is proportions, not totals, but proportions. All right. Now, when that all is done, you're going to hit stat, go over to tests with your arrow key, roll down, and this one is just labeled chi-square test. That's all it says. Okay. And then it'll have observed. Assuming you put your data there, that's fine. Expected is where it will calculate the expected frequencies for you very thoughtfully and store them in whatever matrix you choose right here. But that will probably be B. Why not? You want them to be right next to each other. But you can change it to anything you want. But I recommend you leave it like this. Jump down to calculate. Guess what we see here? We see a test statistic and a p-value, although it just says p, 0.0398. All right. So now what? So they actually went ahead and they did this enormous table and they discovered the test statistic to be what we found. Look at all that work. Ooh. And we were told that the alpha was 0.05. Oh, sorry, alpha. So we know that p less than or equal to alpha implies reject the null and accept the alternative. So the null here is that the two variables are independent of each other. So by rejecting the null, that means that the gender and the beer preferences, uh, oh, they're not here. All right, they're down here. The gender and the beer preferences are not independent. We're rejecting the null. That means gender and beer preferences not independent. And that just simply means that women like some flavors better than men and vice versa. It's that simple. They have different tastes for beer. And that also means that the company, the beer company, will probably want to change their marketing strategy to reflect that. You know, you can see on TV, some ads are clearly meant for a male audience, some are probably meant for a female audience, and a lot of them are meant for either. Like, if the commercial is for tires, well, all right, but if the commercial is for um, ESPN, a football package for like ESPN or something, it may be geared towards male audiences. But anyway, so this one is very straightforward. And so the surprise here is that if you go back to B and look at it, you'll see that it contains the expected frequencies. In other words, if the two characteristics were really independent of each other, this is what they would look like. So if you're curious, you can go look. You don't have to do this. All we really care is that, they're not independent, but you'll see that the proportions roughly 2 to 1 in each case, because that's how many more men there were in the sample. All right. So test of independence, again, pretty straightforward and certainly sped up by having this calculator. Calculating this, I've done this on the board in other classes, doing it from scratch by hand, it's it's very time consuming. And there's so many opportunities to make mistakes. So in other words, when you're doing your mind tap assignments, you might as well take advantage of your calculators. Then we ran into trouble with this last one. I finally figured out later on what was causing the problem. So here we're looking at the testing quality of three or more proportions. Okay. All right. So the null is that the proportions, for example, what if we're trying to find out, let's say that you're Starbucks and you're looking at all the states in the Northeast, and you want to know if the proportion of people who drink decaf is the same in all 6 New England states. Yes or no? Because it helps us understand how to market our product or how much decaf to produce. So they start by assuming that it's the same for all of them. They all have the same preference for decaf. The alternative is that they don't. At least one of them is different. All right. Oh, and this has to be at least three. Because remember, we did this with two earlier. What was that? Chapter 10, I guess. So in other words, If you have only two, you're going to use the approach from chapter 10. It's three or more where this really starts to become very helpful. So the null, of course, is that they're all equal. The alternative is that at least one of them is different. And they later on they'll show us how to find out if we find out that they're not all the same. There's a test we can use to find out which ones are different from the others. So you've got here they're using these three brands of cars, and they're asking these customers, are you likely to buy another one? And we'd like to know if all three are the same. Now, this is where I goofed it up yesterday. First of all, I didn't realize I was entering the wrong data into my calculator. Secondly, it turns out that when we're doing these applications, the matrices that we're using here cannot accept numbers that are not integers. They have to be positive integers. Otherwise, it'll blow up and give us an error message, which I discovered yesterday without having any idea what the problem was. They have to be positive integers. So we have a table, which can be thought of as a matrix, two rows, eight columns. So the dimensions are listed as 2 by 3, right? It's always rows and then columns. And what we should probably do right now is go back to matrix A and enter this as we speak. But first, remember, you have to change the dimensions to 2 by 3. Okay, then just type what you see without the totals, of course. Okay, now what? So if you notice, they are asking us to calculate a matrix of expected frequencies. These are the observed frequencies. These are the Fs. This is how you calculate the expected frequencies, which we certainly could have done ourselves, but there's no need. So you can see how closely this is related to the tests of independence. In fact, having the same proportions means the same thing as being independent. So what we can do now, if you notice, even the test statistic is the same. All right, but here's what we're going to do. And this time I got my fingers crossed it'll work. Um, After you enter the data into your matrix, probably matrix A. Okay, so that we've done. And then what we can do, just like before, is in order to calculate the test statistic and the p-value, um, go to Stat, Edit. Oh, wait, sorry, not Stat Edit, Stat Test, Stat Tests. And once again, pick C, chi-square test. This is probably why they didn't choose to call it chi-square test of independence, because it can be applied to other things as well. The goodness of fit just means goodness of fit. Okay, so I'm seeing the logic behind their naming conventions. Now, once again, make sure it says observed. A, expected B, and then scroll down and hit calculate. And let's see what happens. Well, what do you know? Tonight it worked. And again, it's because yesterday I was putting the wrong matrix in there, but also if they were all integers, it would have just come up with the wrong results, but it refused to run at all because it won't accept anything other than positive integers. So they put the DF there to, in case you want to look up the critical value, but there's no real need because of the p-value. The critical value would mean looking in the table, 2 degrees of freedom alpha, but instead, um, the alpha was, I think it was 0.05. Yeah, there it is. Okay. Remember, that was our null, and the alternative is that they're not all are equal. So in other words, whatever they're testing here, at least one of them is different. So we've got the three companies. Uh, that's right. This is one of they're asking them, yes or no, would you buy this car again? So it's clear that at least one of them is different from the others. It looks like the Impala, the ratio is a little bit low compared to the other two. But, there's a formal test we can use to find out which one it is. Wow, this is interesting. So, first of all, remember the P bar means an average, or sorry, in this case, it's the sample proportion. So we're taking the people, like, if you notice, it's like yes over total for each one of the three. So the P bar, so to speak, is 69 over 125 for Chevrolet. In fact, I'll copy this. I didn't hit it hard enough, I guess. Oh, yes, I almost forgot. Whenever you have something messy like this, you're going to do paste special picture. JPEG is the best, I think. All right. So P1 bar, 69 over 125 is 0.552. 60%. 70.3%. So you know what? It might just be the third one. That's the outlier. Okay, now we're going to use this Marisculo procedure, which means find all of these differences. You notice they're all absolute values, by the way. One minus two, one minus three, two minus three. Now, this, sadly enough, is not in your calculator. But now, of course, this is an absolute value. Negative, so it's negative 0.048, but of course, we're going to drop the negative. Here we have negative 0.151, which of course we drop the negative. And this last one, it's 2 minus 3. All right, here they are. Yeah, I just ran it to a slightly different number of digits than they did. Then, oh my God, look at this catastrophe. Then they want us to put it in here for each of the different pairs. Okay, I guess we better do it. I don't know if they're going to ask you about this in MindTap, but if they do, here it is. So CV stands for critical value. For each comparison, we have a separate critical value. So the subscripts tell you which one we're comparing. So here's our critical value. All right, so the I would be replaced with the 1 and the J with the 2. Now, they very helpfully already looked up the critical value for us. You can see that there's 3 categories, which means 2 degrees of freedom combined with 5 in our tau area, which we just did. It's the same one we did a little while ago, 5.991. So now P1 is 0.552. N1 is 125. And then for 2, we had 60%, 200. All right. Well, they've very helpfully done this for us, so we don't have to spend all night here. 1380, 1379, 3 is 0.1198. Um, but oh, the comparison is over here. I missed it. If the absolute value of the difference between the two is greater than that number, then the difference is significant. Means that they're not equal to each other. Okay. So then they went ahead and they did the calculations here, as you can see. So I'm just going to copy this. So this one is less, more, and less. And that's how you can tell. We already knew that at least one pair of these were different. This is the one. Okay. Oh my God, what a chapter that was. So now we've got some Excel to do. So I'm going to save this real fast. Now let's open them up. So let's see, I think there's 3 of them. Oh, all right. So one is Scott. Here we go. So again, this is chapter 11, 12. And ooh, second. I just realized these were never clicked on, so you can't see them. So I'm going to download all of these. Sometimes the name doesn't really help. That's been my experience. All right, let's see which ones we need. We'll give it a minute to wake up. It's like what I must have done here. Oh my God. So it looks like when I did this class the last time last fall, I must have decided that, you know what, let's type this up nice and neat. And here it is. Look at this. It's beautiful with all the instructions and everything. So this is called Chapter 12, Test of Proportion. So I recommend if you, I mean, it's here if you want it. It's just sitting right there. This is not one of the assignments. Just download it, do whatever. Just don't, just be aware that it's here. I'd forgotten all about it myself. Oh, I'm glad that I put in all this trouble. Look at this. It's great. All right, but this is not what we need right now. This is great for studying or working on the problems. For here, we've got beer preference with annotations, the women and the men, remember? And then we've got Research 230. I don't know what that is. Like I said, sometimes the titles, these came with the book, by the way. I didn't write these titles. Oh, I don't know what this is, but we'll see what we can do with it. And pro loyalty. Definitely saw that one. Oh yeah, okay. All right, so let's see what we're expected to do. Oh, you know what this is? This is Scott. See, the title, no wonder I couldn't find it. Now, the one thing I do want to point out here is that they love in this book, they use it all the time, this technique called pivot tables in Excel. But I personally find them to be horribly confusing. And I know a lot of people feel the same way. So I would never use them unless it was life or death. It's that bad. So instead, we're going to just have a column. We're going to do this ourselves in a clever way that doesn't require these wretched pivot tables. Okay. So what we're going to do is try to calculate how many of these customers are buying from company A. Now, keep in mind, these are non-numerical results. We need to use something a little different. No, not count if they count A. No, I'm sorry. We're not going to do this one. We're going to do count if. With count if, I don't think it matters if they're numerical or not. So we're going to tell it where the data are. I don't know what happened there. So the end of the data set is found in cell uh, B201.
Hey, Professor, which Excel is this?
Oh, I finally realized it's the one that's called Research 230.
Okay, thank you.
You see it there?
Yep.
Okay, good. Because I didn't know that that was the right one. I mean, the title is so meaningless. So, here's where you have to really watch it. Let me just try something here. I thought that's what it wanted. Okay, maybe, you know what it is? I think it doesn't need the equal sign. There it is. All right, that's all it was. Okay. So let me show you one more time what I just did. So the count if means count, but only if certain conditions are met. And B2 through B201 is where the data are found. By putting B in quotes, that's required because this is not a number. If you needed something more complicated, like greater than three or something like that, then you need to do it a little differently. But for this, all we need to know is what letter does it correspond to. And now I just realized it shouldn't be, what am I doing? It's supposed to be A. Sorry about that. That's the, that's right. It's A. So in other words, we avoided the pivot tables by simply using this count if command. So now what I'm going to do just for an experiment, instead of using quote A, I'm going to try D4. Oh my God, it worked. The reason why that's better is because now I can drag it down. Before I would have had to manually type A, B, and C. Okay, so that does work. Whenever you can drag, always go for it. Okay. So we'll drag. We'll confirm that we have the right number by adding them up. You can hit this auto sum button or just manually type equals sum E4 to E6. Oh, now what happened there? Oh, I know what happened. It adjusted the cell references. So, all right, that was my mistake. I did not anticipate correctly. So here's what you have to do differently. We have to put dollar signs here to make sure that it doesn't change those references because the data set is always fixed at B2 through B201. When you drag it down, it's adjusting those if you don't have dollar signs. Dollar signs are a very, very powerful technique in Excel. Once you get good at Excel, you'll use these all the time to lock in your references. That means these are not correct, by the way. Yeah, that's more like it. So let me show you again what I just did.
Sorry, Professor.
Yes.
I was just curious, how do you do the dragging motion? Is there like a special
Oh,
button you have to
oh,
press?
that's the easiest part. Watch this. So let me delete these so you can see what happens. Grab this with your, choose it with your mouse. You have to have this little pointer in the bottom right. Then you must hold down the left mouse button. I'm not sure if it's different on a Mac, but on the PC, it's hold the left mouse button and then just pull it down. Try it on the Mac if you have one. It's very
It
similar to
worked.
this. Okay, there it is. You're going to get a
Thanks.
lot of use out of this. You're welcome. All right, now here, what are we doing? Oh, here's what they want. So these are the E's. These are, remember, we obtain these by multiplying the probabilities by the total. So you'll put, for example, here E equals D10 times $E $7, because we don't want that reference to change. Okay. It'll always stay there. So we can drag this one down too, and you'll have all three of your expected frequencies. Nice. And you remember these from before. These are correct. So I'll
Can
show
you
you
flip
one
it
more
to go
time.
down?
Yes. So yeah, there they are. So we've outwitted the book by doing this instead of the pivot tables. Now you may want to do the pivot tables, but man, you're in for a lot of heartburn, let me tell you. It's just so strange and non-intuitive, and the instructions are so awful that the chances of getting it right are pretty remote. So anyway, I think now what comes next? The p-value. Now they've apparently what have they? Oh, that's so just like we have these special features in the calculator that can do a lot of the work for us. They have something here called I-square test. And in fact, this is, well, okay, the naming conventions are somewhat different, but in order to do chi-square test, we need the actual, and again, you notice how the terminology it can be a little different for every source. The calculator, the Excel, the book. Actual is the same thing as observed frequencies. And then that's followed up by the expected frequencies. And if all goes well, we should have our p-value. Yes, it's a very small number. I don't think we did that. Yeah, we got what they did. We did it with the test statistic and critical value, and we rejected the null. And you can see here the same thing will happen because alpha is 0.05, therefore the p-value is less, and we can reject the null that the proportions are what they told us, okay? So I think that one's done. You can go ahead and save it and fire it over here. All right, let's give you a couple of minutes to catch up. Let me, just in case, I'm going to shrink it up just a bit and I'll show you all the formulas all at once. There we go. So that will do it. That's all we had to do. It doesn't look like much, but it was very important. All these steps were very important. All right, so what was next? Now we had, the next thing we had was Tested. Oh yeah, here's the beer. Okay, this one is labeled properly, I believe. Yes. So, what's happening here is that, now remember, they gave us, these are the observed frequencies up here. We do need to fill in, let's fill in the totals, all right? And then you can just drag this down. Here, the total is a column total. You can just put sum. And then drag that one across. So this is what it should look like. So that's just a reproduction of this table. Now, I'll be curious to see how they expect us to do this one. In Excel, I mean. Oh, all right. Well, all right, let's fill these in and I'll explain what they've done. For the most part, you shouldn't have to do these more than once. Once you get it right. Let's see one. Let's see what they did. Now, it turns out that with the dollar signs, you can lock in just not just the whole cell reference, but just the row or just the column if there's a good reason for it. So they want us to just lock in the 8 because it's row 8 where we find this total. The H5, we want it to go down from light to regular to dark. So no dollar signs for H5. And then, so this is a very clever setup, I must say. Divide again by H with just the dollar after the 8, because that also isn't going anywhere. And I'm pretty sure that we won't have to do this again. All right, let's find out. Let me drag these down. Not just down. Watch this. I can drag all 3 of these across. Oh, no, maybe not. Sorry. No, no, no. I got a little too ambitious. Sometimes you can, though, if it's set up correctly. So that means they must have done something different here. Yeah, they did. I see. All right, here we go. So, well, you only have to type it once. It's H5 times G $8 divided by H $8 because that's the grand total. That should do it. Does that look right? Yeah, that's it. Now, even though we don't need them, I'll feel more comfortable knowing that the totals match up. All right, so we have sum. Oh, good. Oh, good. So if they all line up, except possibly for some rounding issues, then we'll be good. Yeah, they're the same. That's good. So even though it doesn't say so, the one on the top is observed. I'm just going to type this in here. And this is expected. Now, they've got a function for us, a p-value, and they're going to have us do the following. In cell G, looks like that is 16. Oh, it doesn't really matter which one it is, as long as we'll put it here. Equals chi-square test actual. See, this is why I labeled them because I want to make sure we don't get them confused. Actual, expected. Make sure you do not include any of the totals. Yeah, and that's what we got, 0398. And of course, that means that we reject the null because this is less than 0.05. And that in turn means that the gender and the beer preferences are not independent of each other. All right, so I'm going to flip it over so you can see it all just in case you missed something. There's a lot going on there. All you have to do is look away for 1 second and you might lose the whole thing. All right, so I'll give you a minute to catch up in case you missed something. And then you can fire that over here too. I think the third one is the data analysis tool pack one. And so again, we learned some important key details here, though. The idea that you can have dollar signs just around the row or column if there's a reason for it. If it's just a constant, one cell, one constant in there, usually you just put dollar signs on both. Copying and pasting around like this. Sometimes you only want to lock in the row, and sometimes it's only the column. So you can do them independently of each other. So I think that's that for that one. Now, what's left? My mistake. I thought this one was a okay. No, data analysis tool pack. Oh boy, I didn't fill in all the details. Well, this is kind of painful. All right, I'll tell you what, I'm just going to manually type what I see here, just because, we don't have time to do anything else. Small, it's really hard to see them. So it looks like we need in row 5, E5, Yes and no. Wow, I don't know why I didn't do this in advance, but there it is. Oh, well, all right, I'll tell you what. Why don't we take advantage of our newfound skill with the count if statement? Just a bit bigger. Yeah, let's come back to that in a second. Then we have Impala Fusion and Honda Accord. And then we have totals. So what we're going to do is count if to fill these in. The data is in A2 through 501. It's a big data set. Yeah, the thing is here, we need to know two things, which car it is and whether they're likely to repurchase. So this is when the pivot tables theoretically should be helpful. So since we don't have all night here, I'll tell you what, let's just type these in. 69, 56, 120 and 80. 123 and 52. And then we can figure out the totals ourselves. This one can be dragged across the sum command. And then here, the sum can be, you can do sums across rows or columns. I'll you know, show you the formulas in a second. So here's what we, just so you can see what's going on. Okay, once we have this in place, the rest should follow very quickly. All right, so then we have all these commands down here, the very hard to read ones. And so, in other words, these are the actuals or observed. These are the expected. So we can recycle the table itself. In other words, the columns and the rows. We'll just have to delete these guys, and then the totals will fill themselves in. Now, I have to make sure that we're on the same rows as here. Otherwise, we're going to make all kinds of mistakes. The yes is on row 12. Ah, see, we're off by one. So let's move this. Yeah, that'll do it. So that way we can just follow their instructions directly. So for this one, they want I5 times F7 divided by I7, it looks like. Yeah, that would make sense because that's the grand total. No, it's really strange. I don't see any dollar signs in there. I don't understand why not. Looks like they just retyped the whole thing. All right, let's try something. I think if we do this correctly, if I do this correctly, we may not have to do a whole lot of typing. So hold on one second while I confirm this. 78, 124.8, 109.2, 47, 75.2, 65.8. Yeah. All right. So let me show you what I did. If you do this once, you'll only have to type it once. I'm surprised they didn't do that. So here it is. If you type that, you can fill in all the rest of the non-total cells just by copying and pasting or dragging. So it's very, you can see the pattern of the dollar signs is kind of interesting. In one case, we only want to lock in the column, another just the row, and in the third case, both. And then we're just going to run the chi-square test again, like we did before. The only thing that made this one messier is the way it was set up. Once we got these tables straight, we're good.
Professor,
Yes.
how do you move over the whole table like over one or down one? How
Okay,
do you?
watch this. Drag. Make sure you have this little black plus here. Hold with the left mouse button across and then down. Oh,
No,
okay.
sorry, I meant the entire you know how you took like the expected table
Yes.
and you like moved all of the information including the text down one.
Oh, yeah.
Yeah.
If you like when I screwed it up like that, let's say I have this and I want to move it down. I selected the whole thing, Control X for cut, paste, put your select here, Control V for paste. See what I did?
Okay.
So Control X for cut. Move to the where you want it to go. Control V for paste.
Okay.
Another cool. You got it?
No, I don't think it works on Mac. I'm not sure what the
Oh, all right. I'll tell you what. I just realized that it will not make any difference where the expected table is because you're going to use the same cells anyway. Um, Oh, no, wait a minute. No, that's going to be a problem because the chi-squared test will be a problem. Um, doesn't work.
Yeah, I don't know. I'm trying doing the control X, maybe
Well,
F.
now keep in mind,
Oh, maybe wait, I think I got it. I think it was
oh,
command. Yeah.
oh, does command do work? Okay, because I'm never sure what's equivalent to what between the two
Yeah,
of them.
I
Did that
believe
work?
I think that worked. Yeah. Yeah, that
Oh,
works.
good. Wonderful. All right. Yeah, because I have a PC right here in front of me, although I do use a Mac too. I don't know it as well as I know this one. And so this part you're all set with?
Yep.
All
Thank you.
right. So according to, yeah, the instructions, they want, if you put p-value in G15, oh, you know why it's off? Just because they didn't put totals. All right, that's fine. We'll just put it right here. It makes no real difference where we put the results. Oh, by the way, don't put equals. I don't know why I did that. P-value, if you just type, it'll put exactly what you put in there. It doesn't interpret that as a formula. So here it is. It's chi-square, like we did in the last one, test. And again, it's just a question of telling it where's the actual, which is the observed. Make sure it's only those. Do not include any of the totals. And then we have expected. Yeah, let's keep our fingers crossed. 019, yeah, that's what we got. 01934. All right, anyone need to see that again? All right, I'll show it to you anyway. So yes, in other words, it's comparing the expected with the observed or actual to come up with your p-value. Wow, that was a lot of intense Excel. I think it's going to get more complicated as we go into the next two chapters. But on the other hand, just think how light your schedule will be in the fall if you already have this class done. That should bring a smile to your face. Is that why everyone is here? Because you wanted to lighten up your schedule? I'm going to say yes. All right. Good. That's what I'd like to hear. So in the fall, you won't be so overwhelmed with all your classes because the one of the more complicated ones is already finished. When I was in college, I did all my calculus classes during the summer for that reason, because I knew it would be a lot of work. And during the summer, although I did work to a certain degree, still, it's easier to do it that way than to me than to do it during the school year. Anyway, so all right, this is done. You can save it and send it to me. And that's it for tonight for the Excel. All right, there's no more. That's it. We're done. So now here's what I want to do. I did mention before that I've written a couple of problem sets for 9, and I'm working on the ones for 10 as we speak. I was thinking that maybe Thursday we could work on those problem sets because if I manage to get the midterm ready over the weekend, um, that will make it easier for you to get started on it. I mean, you already may be ready as it is, but I think once you see new problems, it might make things even a little easier. Especially at the very least, it'll help refresh your memory of what we were doing. So, like tomorrow, right now we're about to start 13. If we could do 13 tonight and tomorrow, then maybe Thursday start the reviewing of the chapter 9 and 10 problem sets. I think that would make the most sense. Good. Now 13, now by the way, they're all of these chapters, as you can tell, have something to do with hypothesis testing. This is the common thread throughout all of them. Chapter 14 will be very significantly different. It will also turn out to be really crazy important for people who are really going to go on and use this stuff in the real world because it introduces us to a technique that is widely used to draw conclusions from real world data. And there's a lot of background that we need to cover before we get into it properly. And it's going to seem pretty scary at first, but once you get the hang of it, you'll see that it's not really that difficult. And Excel can give us a lot of help with it. The calculator too, but Excel can be especially helpful with chapter 14. 13, I think there might be a data analysis add-in for that, but it's kind of involved. It's kind of a complicated type of situation. It has its own unique set of notation, terminology that takes a while to get used to. So we'll approach it slowly. We'll get used to what's going on. And then, we don't want to rush it. Anyway, so let's see what is going on in chapter 13. All right, well, I don't have it open, so I'll have to go into Bright's Blackboard. Here we go. Oh, by the way, in chapter 13, the F distribution makes a comeback. We won't be using chi-square in 13, but we will be using the F distribution. Well, we really only just got started with the F distribution. We only needed it for one quick example. Here it's going to be used all the time. By the way, let me open this up. It says here ANOVA example. I'm wondering if I wrote some notes. Oh no, this is one I may have just been going over this in my class. I guess I didn't want to throw it out. We'll see what this. Don't worry, we'll get to it. Oh, this one has two parts. Oh my God. Don't be intimidated by it. Like I said, it will seem very scary at first. So what we're doing here, the procedure we're following is called analysis of variance, but most of the time when you see this, it's abbreviated ANOVA. Okay, that works out rather well. Rarely see it spelled out. And Excel has this, of course. It has several potential applications, but the most important of them is that this enables us hypotheses, of course, about the equality of three or more. Now, of course, in chapter 10, we saw how to compare two means, but when we get up to three or more, it requires a much more complicated procedure. That's what this is for. The analysis of variance makes it possible to compare three or more means at the same time. All right, so that's where we're going. Now, by the way, I want to mention as a side note here, that document reminded me of this. ANOVA has been heavily used in agriculture. I'll tell you why. Let me show you why it's so helpful for agriculture. Imagine yourself in the following situation. You're a farmer now, all right? Yeah, you went to Gabelli, but you're using it for farm management, okay? You're trying to figure out the best, how to manage your farm the best. You decided to get away from New York City and buy a corn farm in Iowa, okay? And now you're growing crops. One of the things that you really want to find out in a scientific way is this. You've got, let's say, three fertilizers to choose from for your corn. Now, they're all going to tell you they're the best and they have the best yields, but we want to demonstrate. We go out on our land and we decide to set up an experiment. All right, so we'll call these F1 for fertilizer 1, 2, and 3. And what we do is on each plot of land, um, let's say 1 acre each, we write down the yields using the different fertilizers. Okay, so this would be, let's say, 8,000 bushels of corn. Let's say these are our results. So each plot of land has been planted with corn using a fertilizer. Now, we're trying to hold everything else constant here. So, for example, this might be the land that gets the most rain in the northeast corner of our farm. And these might be the acres that are furthest away from water. And maybe these are the acres that are in the center of their property. In other words, we're trying to hold everything constant here except for the fertilizer. So you can see fertilizer 1 has an average, we'll call it X bar 1, of 5.75. One is 6.5. And the last one is 7.25. So the question is now, of course, they're not identical to each other, but what we're trying to find out is if the three fertilizers have more or less the same mean, which would indicate that they're all equally effective. Or is it possible that one of them is better than the others? So the thing is, even though these means are not the same, it might be that they're close enough that we can conclude that they're the same. We need to have hard evidence to indicate that at least one of them is different enough that that is now the best choice. So this is in a nutshell what we're about to do. We're going to have data organized this way, and we're trying to find out if the three or more means are equal to each other or not. Now, there's a more advanced version of ANOVA where there's a second variable involved, where you might have plots of land that are arranged by their rainfall as well as their fertilizers. We're not going to do that here. We're going to start with this approach because it's simpler Okay, and for what we're doing here, this is all we need to know. Are the fertilizers equal or not? And of course, we can use this for any area we want, but you can see why agricultural economists would have used this for their, different farming projects. Anyway, so what we're really doing here, which is not normally the case in business, instead of being given a bunch of data, we're actually carrying out some kind of an experiment. It's almost like we're scientists. Okay. In other words, we have some control over what's happening, how the data is generated, which is not something we've seen before. So it's important to do this correctly. So they're making the case here that what we've done up to this point could be defined as an observational study because we had no control over any of the outcomes. So, in other words, like remember we had the women and the men drinking the beer. We didn't, for example, make sure that all of them are above a certain age, let's say, or have a certain income or anything along those lines. We just said, okay, men and women, come on in here and drink the beer and let us know which ones you like the best. We had no other control over anything. But with an experimental study, it's the other way around. We're making sure that we know exactly how each, in this case, acre of land is being affected by the different factors. We know whether it has a different fertilizer. We may set it up so that we are looking at the rainfall or the temperature or whatever. So ANOVA is really meant for experimental studies. And it's this way, it's easier for us to say this happened and therefore this happened. Like we use fertilizer 3 and therefore the crop yields went up. And those are, of course, known as cause and effect relationships. Okay. Now, ANOVA can be used for either case, by the way. It doesn't have to be an experiment. It could be a bunch of data that just happen to come together, but it's usually more important for experimental data. Okay. But yet, yes, we can always use it. Now, by the way, just a side note here, even though I did tell you that this is meant for 3 or more means, you could actually use it for 2 means. But if you're going to do that, it's probably easier to use the approach we had in chapter 10. There's a lot of calculations here. So that's why this is normally saved for 3 or more means. Okay, just because of time. Plus, this is a very complicated process. Now, we're not going to necessarily get too carried away with all of these cases. There's certain ones that are more important than others. Like the first one, the completely randomized design, we're definitely going to work on that, where you're just basically saying the land is what it is. We're just going to plant some fertilizer and see what happens. Whereas the randomized block design and the factorial experiments are where we exert some kind of control over the results. Like we try to control for rainfall or temperature or whatever the case may be. That makes things a lot messier. Okay, so this is when we're going to really need the help of the calculator and Excel. All right. Now, unfortunately, there's a lot of terminology that we need to get used to. So, and some of these, you're like, well, how can they pick these names? They don't tell me anything. So, but if you look at my farming example, those fertilizers are referred to, or the fertilizer is referred to as a factor because that's what I am changing. Okay, so here we say that the fertilizer is a factor. Now here there is only the one factor. Okay, so you have to get used to that. If I also was studying the rainfall at the same time, there'd be two factors, rainfall and fertilizer. But here we just have the one. A treatment, yeah, see again, I think this terminology is absolutely insane. Is a level. In other words, each of these is a different treatment. F1 is a treatment, F2 is a treatment, F3 is a treatment. Okay. All right, we'll get used to this. Experimental units in this case would be the plots of land. And again, the completely randomized design is the one in which the treatments are randomly assigned to the units. In other words, here, um, the fertilizers. Oh, by the way, I just do want to mention here, I didn't mean to indicate that this graph, um, these are just meant to be a summary of the results. The land itself doesn't necessarily look like this. In other words, you might have something like this. Let's say you create this checkerboard pattern on your land. And you just randomly choose F's will go. Oh, sorry, there is no four. Now, of course, we have to be consistent with this table. In this table, we've got four of each, 12. Oh, got one row too many here. I'm not sure if I can erase. Uh, I'll tell you what. Let's see if I can fix this. I got one too many F1s. Okay, I think we're good. And then we copy the results into the table. Okay, this is the actual land itself. Chosen for each plot. And so the result gets copied back into this table. Okay, so that way each column is just one fertilizer. All right, so I just want to make sure that it's clear. And this then becomes a completely randomized design. Whereas if, let's say instead, the first column is only F1, the second one is only F2, and the third is only F3, that's a different matter. That you're doing that on purpose. Um, and so it's no longer randomized. Instead, depending on what you're trying to do, it's randomized block or factorial. We'll get to those later. All right. So here we go. Here's the null and the alternative. I'm sure you're not surprised by any of this. It's very similar to what we saw with the three or more proportions. They're all the same or they're not. Okay. All or none. And that means that this is a right test. And as I mentioned before, the test statistic and the critical values based on the F distribution. So we're going to reintroduce our friend, the F distribution, probably tomorrow. And the test statistic, everything is based on the F distribution because, well, I mean, because you're dealing with multiple populations. The chi-square is only meant for one at a time. Okay, so the math behind the scenes here is pretty overwhelming. We're not going to try to even question it, but um, all of these test statistics were chosen for a very specific reason. Um, and this is what mathematical statisticians do all day. They derive results and they prove that, this statistic is useful under these conditions. Us practical statisticians use this stuff to get results, okay? So give me a test, I'll run it, and I'll draw some conclusions. That's how it works for us. Especially, in the economics department, you wouldn't have economics without statistics. It couldn't exist. Um, I wouldn't go that far with some of the other business disciplines, but yeah, everything in economics has something to do with statistics. Even business disciplines that are more people oriented, like marketing, somebody's got to do the research. You got to have a way of drawing conclusions from the data that you have. So, like if a company's trying to decide whether or not to advertise on TV, they've got to have all this information that shows them, what is likely to happen if they do. So, marketing, some people in marketing are actually statisticians, and this is what they do all day. And I know somebody who does, well, he's a professor, but this is what he focuses on. And he's one of these people who lives for statistics. It is his life. Not that we don't love statistics, but we have other interests too. Not this guy. This is why he gets up in the morning. Okay. So they're the ones who develop all these results for us. All right. Anyway, what's coming next? So, of course, if we reject the null, that means at least one of these is different from the others. Now, I've said this before a few times. Every one of these statistical tests that we are looking at is based on some assumptions or other. Here, one of the key assumptions, two of them actually, three, sorry, there are three here. The response variable. Now, by the way, here's some more terminology. We're so used to thinking of independent and dependent variables. Have to change it, don't they? So here they're going to call that the response variable. And the other one is sometimes called the control variable, but it has other names as well, which we'll encounter as we go along. So when you run into these terms, don't be deceived. Okay. They love to throw these at us. Anyway, so they're going to assume three things. Number one, the response variable which in our case would be the crop yields, is normally distributed number two, the variance of the response variable. And now they're calling them populations. So like here, um, each different, the data which we draw or apply the factors to, meaning the fertilizer here, three columns represent data drawn from three different populations, okay? So that's what we're assuming. There, it's like we have three separate samples, each drawn from a different population. So the variance of Y is the same for all populations. Again, here there are three of them. And the observations that we draw are independent of each other. That's a lot of assumptions, but without that, the results will be very much compromised. So, all right, anyway, I think since this is such a complex topic, we got an awful lot of work done tonight. I think it's plenty of time to wrap it up. So the plan is we'll do more of this tomorrow, and then Thursday, I think we'll work on those practice problems from chapter 9 and 10. Okay. That way you'll be 100% ready. And by the way, there's another document that's going to go in there too called the sample midterm number 1. So there'll actually be 3 documents that we can review to get you 100% ready for the midterm, which by the way, don't forget is not due until the last day of the class, which I think is August the 7th. So I think that's what we're going to be doing. We're going to be very busy this week. So, all right, I guess we'll stop right here and I'll see you all tomorrow. Are you too exhausted to go home? Maybe.
Thank
That
you.
was a lot. All right, see you tomorrow.
Thank you.
All right,
See you
bye.
tomorrow.
Okay, see you tomorrow.